Alright guys, welcome back. Video number 2, we're going to go over pages 3 and 4. Alright, let's start off. Let me shrink this here. Pow. Alright, cool. Alright, cool. So question number 12 is literally just an extension of the previous question here. And so it says how many moles are in 354.2 grams of H2O2. So always underline what you have, and then I always kind of circle what I'm trying to get to. So you always start with what you have. I'm going to rotate this here.
Okay, great, we're good.
For sure. All right, cool. So if I start off with 354.2 grams of H2O2 over 1. I'm going to go from grams up here to grams down below. So I'm going to have grams of H2O2 up here, and I'm trying to get 2 moles of H2O2, right? So in 1 mole of H2O2, how many grams are in there? So that's when we're going to have to do H2, so that's 2 plus 16 plus 16, since there's 2 oxygens, so that's 32 plus 2, that's 34 grams. And so you would multiply these two numbers over here and divide by 34, and that would give you your number of moles of H2O2. Cool. Number 13, how many molecules, this one's fun, are in 5 moles of NaCl? So always start with what you have, 5 moles of NaCl over 1. If I have moles of NaCl up top, I need moles of NaCl on the bottom, so 1 mole of NaCl, and then I'm trying to get 2 molecules. Okay, if I have 1 mole of NaCl, how many molecules do I have? I have 6.02 times 10 to the 23rd. Bam. Alright. What is the mass of 3.45 moles of CaOH2. So we're trying to get to mass, we have moles. So if I have 3.45 moles of Ca parentheses OH2 over 1. Alright, if I have moles of that, I need moles of this down below, CaOH2. And then I'm trying to get to mass, which is in grams, right? Grams of CaOH2. Now, let me pull up my periodic table of elements here. And so in 1 mole of CaOH2, how many grams are in there? And so I'm going to do this. So we have, oh, sorry. There we go. Perfect. All right, so I'm going to do the molar mass of calcium, which is 40, yep, we'll just say 40 plus 2 oxygen atoms, that's going to be 72, plus another 2 hydrogen atoms, that's going to be 74. So in 1 mole of this, there are 74 grams. And so you multiply this across, and then you're going to get something, grams of CaOH2. Once again, if you guys have any questions, what I would do is, as you guys are reviewing this video, what I would do is kind of put an asterisk or a star next to some of these questions where you have some misconceptions, or if you're looking at this and you're reading and you're like, dude, I'm completely lost, yeah, just definitely put an asterisk next to it and then come ask me a question regarding that one in a bit. All right, my favorite empirical formulas, and so I'm going to verbalize the steps for empirical formula, right? So remember, an empire or an empirical formula is the simplest formula. That means that the simplest, most reduced version of this particular molecule, right? So the steps for that, yep, I'm still recording. Okay. Step number 1, obtain the mass of each element present in grams. Determine the number of moles of each type of atom. Divide the number of moles of each element by the smallest number of moles, right? And so, here we go. And so what you're going to do is you're going to make sure that all of these are in grams, which, hey, they are all in grams. So thank goodness for that. We don't have to convert them, right? And so the question says, a sample of caffeine is found to contain 49.48 grams of carbon, 5.19 grams of H, 16.48 grams of O, and 28.8 grams of N. Calculate the empirical formula for caffeine. And so here you go. So step number 1's already done. We're in grams. Step number 2 is trying to figure out how many moles of each substance we have. And so here we go. If I have 49, can you guys see that? Yeah. All right, 49. Let me zoom in here. Bang. Hey, there we go. Look at my hands. All right. 49.48 grams of C over 1. And I'm trying to see how many moles of that I have, right? And so if I have grams of carbon up here, I need grams of carbon down here. There are, I believe, 12 grams of C in 1 mole of carbon. Bam, bam. That's going to give you a number, right? So blank mole. And then if I have, what's my next one? That's going to be 5.19 grams of hydrogen. So 5.19 grams of H over 1 times 5 grams up here. I need grams down here. So grams of H. So there are 1 grams of H in 1 mole of H. And that's going to give you some number over mole. Right? And then I'm going to split the screen over here just because I'm running out of space. I wrote too big. Sorry about that, dudes. All right. So if I have 16.48 grams of O over 1, in 1 mole of one mole of oxygen has 16 grams, so 16 grams of O in 1 mole of O. And then the last one is going to be nitrogen. Huh. All right, so if I have 28.8 grams of N, I know that in 1 mole of nitrogen, there are 14 grams. And so that's going to give you a number. Now, you figure out this, and then what you're going to do is you're going to divide by the smallest number. So you're going to divide all of these by the smallest number. I'm going to pause for a quick second. I'm going to calculate these on my phone, and then I will come right back. Alrighty, guys. Awesome. So what I did was I just calculated all of these. Bam, 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 bam. You just got ninja'd, right? So now, what you're going to do, the last step is trying to figure out the smallest number of moles and divide it by all of them, right? So the smallest one is going to be 1.03 because, and it's oxygen. Now, what we do is we take all of these numbers, so 4.12 moles of C divided by 1.03, 5.19 moles of H divided by 1.03, and then we take 1.03 moles of O divided by 1.03. That one's going to be an easy one. And then we do 2.05 divided by 1.03 moles of O. Okay. All right. So we're basically dividing all these numbers by 1.03. Now, here's what we get, right? We're going to have, if we divide all this out, we get carbon, and that's going to be 4. This divided by this, H, is going to be 5. This divided by this, obviously O is going to be 1. And then this divided by this is going to be N2. This one's going to be like 1.9999, so you can just round it up to 2. So your empirical molecule or your empirical formula is C4H5O1N2. This is a ninja one right here. You don't have to include it, but I just included it for the purpose of this example. Now, obviously what I've done is I've run out of space. So you're going to have to do number 16 all by your lonesome. Sorry about that. All right, let's move on to my second favorite. Actually, this is my favorite because this requires the most amount of work. Which is the molecular formula. So remember we did empirical, and then molecular formulas, right? Now, alrighty, so let's get into molecular formula honors. So, ultimately the formula that you need to figure, or that you need to kind of start or catalyze this problem solving is you're gonna need the molar mass of the given, and then they give it to you here, I'll go over that in a second, plus, or divided by the empirical mass, or the molar mass of the empirical. So let's read this problem. Okay, So hydrazine can be used as rocket fuel. A 6.4 gram sample of hydrazine is found to contain 5.6 grams of nitrogen and 0.8 grams of hydrogen. The molar mass of hydrazine is 16 grams per mole. Determine the empirical formula and the molecular formula of this compound. So to solve this, right, we need to solve for molecular. This is the formula that we use, right? And so we are already given the molar mass. Thank goodness, it's 16, but we have to figure out the empirical molar mass, right? In order to do that, we have to figure out the empirical formula. Now, those are the exact same steps as we did up here. So now let's do the same thing. So if you always start with what you have. I have 5.6 grams of nitrogen, 5.6 grams of N over 1, and I'm trying to get to moles, right? So I can divide by the least common one. So I have grams of N down here, and there are 14 grams of N in 1 mole of N, right? And that's going to give me a number, blank mole of N. My second molecule in there is hydrogen. Oh, that's a simple one. So that is 0.8 grams of H over 1 times 1 gram of H per 1 mole. Right, and so this one we can just already assume it's going to be 0.8 moles of H, and so now we have to figure out this divided by this is going to give us some mole of N, right? So let me, if you break with me here for one quick second, I'll go ahead and figure that out. Actually, I'll just... Alright, so I just ninja'd you again, so that's 0.4 moles of N, 0.8 moles of H. Remember, if we're trying to figure out the empirical formula, we divide by the least common one. So we're going to divide both of these by 0.4. So I'm going to get 1 here, 1 mole of N, 1 mole N, and then I'm going to get 0.8 divided by 0.4 is 2 moles of H, right? Now I'm going to move this formula down here because I'm running out of space, sorry. So my empirical formula would be N1H2, right? And so that would be the empirical formula equals empirical. Now, let's bring this puppy down here as well. So let's plug everything in. So the molar mass is 16 grams divided by this number here, right? So N has an atomic mass of 14 plus 2 H's, that is 16. Oh, that's easy. 16 grams of that. So this is the molar mass that was already given. This is the molar mass of the empirical formula that we figured out, right? So this is going to be 1. Now, we're not done yet. So if we take NH2, we have to multiply this number by this number. Lucky for us, that would just be N1H2. Now, if this number was 7, for example, right? We'd have to multiply everything by 7. So this would be N7H14, right? And so just because we got lucky and got a 1 doesn't mean that it's necessarily going to work out that way. Perfect. All right. Once again, number 18, it's going to be left to you because I am running out of space. Oh, my favorite one. All right, this is the second page. We're talking about chemical reactions. Let's see. So, just this practice, what I'm going to do is I'm going to have you guys write the type of chemical reaction. So, if I'm looking at number 19, notice that Na starts by itself, and then it switches places with this molecule here, and so Na switches over here, and then you end up with H2 being by itself. So really Na just switched, and so that would be a single displacement. Fe plus S would give you Fe2 plus S3. So since that is 2 molecules coming together make 1, that is a synthesis. Al2O3 gets broken down into aluminum and oxygen. That's decomposition. I'm just going to abbreviate it as DEC. Let's see here. Ooh, this one's a fun one. H2SO4 plus NaCl gives you HCl plus Na2SO4. Notice, let's see here. Let's see where Na goes. So Na starts off with Cl, right? And then it ends up with SO3. So that's one change, right? One replacement. And then now let's look at H2. So H2 starts off with SO4, but then it ends up with Cl, so that's 2, so that's a double displacement, or double D. All right, this one's an easy one. Millie, this one's for you. Anytime you have something plus oxygen and it produces CO2 and H2O, this is always a combustion. Now, this problem set didn't actually ask you guys to label them. I am, so now it's asking you guys to balance them. So let's figure out how to balance them over here, okay? So, when you balance something, you always look at the left side of the equation first, and you want to make sure that the same atoms are on the right side of the equation. So Na, you have one nitrogen or sodium atom here. You have one over here, so those are balanced. You have 2 hydrogens here, but you have 1, 2, 3 hydrogens over here. So you can't really put a number in front of here that's going to get you 3. So let's just skip the hydrogen for now. Let's go to oxygen. I have 1 oxygen here and 1 oxygen here, and that is balanced, right? And so perfect. But let me give you a quick heads up. So we have 3 hydrogens over here, but we have 2 over here. So the easiest strategy that I use, and I'm sorry that I use number 19 as your first example. I promise you the rest of these will go really, really quickly. I want to make this side even though. So what I can do is I can put a 2 here. So that'll give me two sodiums, 2 oxygens, but it'll also give me 2 hydrogens. So total H's for this side is going to be 4. And now what I have to do is I can go back and balance sodium, right? So sodium, that's going to be 2. But now I have 4 hydrogens over here on this side. And then I have 2 over here on this side. So I can put a 2 here. So 2 times 2 H's is 4. But now that means that I also have 2 oxygens. So let's check my math over here. 2 times 1 over here, that's going to be 2 oxygens, right? So everything's balanced. Now, let's look at number 20. I have 1 iron on this side, 1 sulfur on this side. I have 2 irons on this side, so I can just put a 2 here. I have 3 sulfurs on this side, so I can just put a 3 here. And then that's balanced, so this one I can just leave blank or put a 1 in there. Let's look at this one, aluminum 2 at O3, AlO2. So let's do aluminum first. I have 2 on this side and 1 on this side, so I can put a 2 there. And then for this particular one, I have 3 on this side and then 2 on this side. That's a bummer, right? So I have 2 on this side and 3 on this side. Let's make this side even, right? So let's put a 2 here. So now I have 4 aluminum, so I'm gonna have to change this to 4. And I have 6 oxygen, and then I have 2 oxygens over here, and I can put a 3 to have 6 oxygen together. So now let's do this big one over here. Let's see here. Let's do hydrogens first. So I have 2 here, I have 1 here, so I'm going to put a 2 here, see what happens. Those hydrogen is balanced. Let's look at S's. I have 1 S over here, 1 S over here, that's balanced. O's, let's get pretty crazy with that one. I have 4 here, and I have 4 here. Oh, that's easy. And then now let's look at, what else do we have left? Chlorine. I have 1 here, and then I have 2 times 1 chlorine is 2 here. So let's put a 2 there. Now let's look at my sodiums. I have 2 NAs on this side, and then this times this, I have 2 NAs on this side. Let's look at combustion formulas. Anytime you have a combustion formula, the easiest way to do it is go C's first, H's, and then O's, right? And so let's peruse through this puppy right now. All right, so we have 2 carbons on this side, 1 carbon on this side. I'm gonna do a 2 there. And then so now those 2 are balanced. And then let's do H's, right? H's, let's see, I have 6 over here, 2 over here. I'm gonna put a 3 there. Those are balanced. And now let's look at my O's, right? So let's see here. I have 2 times 2 is 4, and then 3 over here. And so that's going to give me 1, 2, 3, 6. Wait, I'm sorry. I'm looking at different directions, doing the math at the same time. 4, 3. So that's 7 oxygens. And then I have 2 oxygens over here. And that's a... And then driving to that, right? And so we're going to switch that number up to 2 over here. So if we do that, in short, that basically makes this number 4, we're going to have to make this number 6, and then of course this number is 7, so 4 times 2 is 8, 6 plus 6 is 14, so this and this, and that's how you would balance that one. Try not to expect one like this one where you have to like keep guessing and guessing and guessing numbers. You should be able to figure out the ones on the test with just by using C, H, and O first, and then not having to guess. So let's look at this one. I'm going to give you guys a lesson on number 24, but I'll show you guys how to do it. So hydrogen and oxygen react to form water. So H2 plus O2 will give you H2O. And let's balance that, right? And so you have 2 hydrogens on this side, 2 hydrogens on this side. That's balanced. But you have two O's on this side and 1 O on this side. So I'm going to put a 2 there. And so that makes 2 oxygen here. But now this makes 2 times 2 is 4 hydrogen, so I'm going to put another 2 here, and so that would be your balanced reaction. Iron metal reacts with oxygen to form iron 3 oxide. Remember, iron 3, this little Roman numeral gives you the charge of iron, so Fe plus 3 plus O negative 2, right? That's with the negative 2 charge. Remember, we have ninja crosses here, and the formula would be Fe2O3. So that's what you're going to produce. And you have iron reacts with oxygen, so Fe plus O2. And so this is when you're going to have to balance it once more. You have 2 irons on this side, 1 on this side, so you're going to put a 2 here. You have 3 irons on this side and 2 on this side. Let's make this side even, so let's do 2. So I have 2 times 3 is 6, and I'm going to put a 3 here to balance that out. But now you have 2 times 2 is 4, so you're going to have to change this one to a 4. Like I said, I'll give you guys a lesson on number 24. And then so we have potassium chlorate breaks down into potassium chloride. I'm going to do a whole group lesson on this particular one as well. And then now let's move over to you guys' favorite, which is stoichiometry. All right. There we go. So here we go. A chemist burns 7.35 moles of aluminum in air. How many grams of solid aluminum oxide will be produced? So you always start with what you... Oh, lucky here. You guys already have this balanced equation. So you always start with what you have, 7.35 moles of aluminum. So 7.35 moles of aluminum over 1. And what are you trying to get to? You're trying to get to grams of aluminum oxide, right? And so in order to do that, we're going to do our super duper long conversion. So if I have moles of aluminum up here, I'm going to have mole of aluminum down here. What am I trying to get to? Aluminum oxide. And so aluminum oxide is right here. So Al2O3 moles of Al2O3. Now, what do I put here in these blank spots? Well, I'll have to look at my balanced equation. So in 4 moles of aluminum, there are going to be 2 moles of aluminum oxide produced, right? Now, if I have moles of aluminum oxide up here, I need moles of Al2O3 down here, and I'm trying to get to grams of Al2O3. What do I put here? Well, the molar mass of this, I'm going to do whatever the molar mass of aluminum is, times 2, plus the molar mass of oxygen, times 3 as well. So that number there, you're going to solve this, and you're going to get some number, grams of aluminum 2O3, right? Now, let's go to number 26. How many moles of chlorine gas, so we're trying to get to moles of chlorine, are needed to completely react with 1.045 moles of sodium? So we always start with what we have. We have 1.045 moles of sodium, 1.045 moles of Na over 1. Right, if you have moles of Na on top, you need moles of Na on the bottom. You're trying to get to moles of chlorine, so Cl2 here, moles of Cl2. So what do you put in these blank spots right here? Well, you have to look at your balanced equation. You put a 2 there, and then you put a 1 here. And now if you have moles of Cl2 on the top, you need moles of Cl2 on the bottom. Or actually, we're done, because the equation is only asking you for moles of chlorine, so we don't have to actually do anything anymore, right? So all we have to do is we cross our units off here, and we're left with moles of chlorine, which is what we want. So you multiply across and you divide by 2. All right. So now let's do this particular one. So this is a reverse combustion equation, which is pretty cool. So 15.34 grams of carbon dioxide combined with water, how many grams of glucose are made, right? And so in this particular one, it's not balanced. You're going to have to balance it ahead of time. And so here we go. So let's do carbons first. Let's do the CHO. So 1 carbon here, 6 are here. So I'm going to put a 6 here. And then let's do H's next, right? And so we have 12 H's over here, 2 here. So that's going to be 6. And then that'll give us that particular one. Let's do O's finally. So how many O's do we have? Well, in this side we have 8, right? 6 and 2, that's 8. In this side we have 6 times 2, that's 12. Plus another 6, that's 18. So I have 18 O's over here. And then, so let's see here. If I have 6 O's here, I can put a 6 here as well. And that will give me 6 times 2, that's 12. Plus 6 is 18. And this guy gets left by himself. And so let's do our molar conversions now. Or our stoichiometry, I should say. So if you start off with 15.34 grams of carbon dioxide, so 15.34 grams of CO2, sorry, that's a 5, over 1. What are you trying to get to? You're trying to get to grams of glucose, which is this thing right here. So if I have grams of CO2 on the top, I need grams of CO2 on the bottom, grams of CO2, and trying to get to moles, right? Mole of CO2. Now, in 1 mole of carbon dioxide, there are 44 grams, I think, 44 grams according to your periodic table. And so if I have moles of CO2 up here, I need moles of CO2 down here. I'm trying to get to glucose, so I can now do my mole of C6H12O6. What number goes here? Well, that is my CO2. I have 6 moles of CO2 for every 1 mole of glucose. And then if I have moles of glucose up here, I need moles of glucose down here, mole of C6H12O6. And so, and then I have grams of C6H12O6 up here. In 1 mole of sugar, there are, I think, 180 grams. And so that's how you would solve that. And then you would find the grams of glucose that are being produced. That concludes this video, guys. Sorry for the length. And then you'll see the final video posted up in a second.